Hello, everyone, and welcome to The Wrong Kind of Viral, What Happens When You Don't Practice Observability. Today's webinar is sponsored by Honeycomb and produced by Actual Tech Media. My name is Keith Ward. I'm with Actual Tech Media, and I'm truly excited to be your moderator for this special live event. Now, before we get to today's event, however, we do have a few housekeeping items you need to know that'll help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. We'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. Now, that Q&A panel is also the place to let us know about any technical issues you might be experiencing. The first thing you want to do if you've got any problems with audio, slide advancement, anything else, is to do a browser refresh. That'll usually fix everything. If that doesn't work, let us know in the Q&A and we will provide further technical assistance, I promise. All right. Next, in the handout section of your webinar control panel, you'll find a number of important resources, including a link to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics. You'll also find links to our Actual Tech Media Events Center, which has our calendar of upcoming events. Check those out, as there are likely to be several that you'll want to catch. Third, at the end of this webinar event, we'll be awarding a $250 Amazon gift card to one lucky registrant. Now, of course, you must be in attendance during the entire event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. And finally, one of the great benefits of this event is the opportunity to ask a question of our expert presenters. To help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. Now, after the event is over, we'll look at all the questions that come in, pick out the very best one, and contact that prize winner. So lots of ways to win today. And with that, let's get to today's fantastic content. I'm really looking forward to this. It is my pleasure to introduce you to our host today, Jessica Kerr, Engineering Manager of Developer Relations at Honeycomb. Jessica, welcome. The floor is yours. Please go ahead and introduce your fellow experts.
Thank you, Keith. I'm happy to be here today to talk about observability and what has come before. And I've brought you some special guests who also love to talk about this topic. This is Austin Parker, and they are a maintainer of Open Telemetry for many years. They've been involved in observability and how do we know what our software is doing for, I don't know, how long, Austin?
How long indeed? Gosh. Hard to remember, actually. I was an open tracing maintainer before being an Open Telemetry one, so I guess really, certainly the past like 5-6 years, this has been my full-time gig.
Which is a long time in this space. And we have Martin Thwaites coming to us all the way from Manchester, England. And
Hello.
Martin he's my team member, and he's been an observability advocate for, again, longer than I go back in this space.
Yeah, I was talking 8-9 years ago about logging and metrics and easy mode stuff like that. Yeah, it's been a while.
Yeah, and yet we've all been developers for quite a bit longer. I've been a professional developer since the last millennium, just barely. And it's only more recently that we're talking about this kind of visibility into our software as developers. But there's stuff that's been around longer. And I want to ask y'all a history question, because this has been puzzling me for a while as a developer. What the heck is APM? Where did it come from and who is it for?
I mean, should we just spend the time working out what other acronyms of APM might be, other than application performance monitoring?
I did.
Is it monitoring or management? That's the first question.
Oh, the M in APM.
Yeah, we got first principles this.
So it's definitely application performance.
I've also seen it referred to as portfolio.
What?
What?
Yeah, knowing what applications you have.
All right.
I do think it
Wow.
is interesting because, as some might know, I worked for past 5 years or so for a company called Lightstep, which was acquired by ServiceNow a couple of years back, and I've since left that role in order to, take a break and kind of see what's going on in the wide world of observability. But it's very interesting going from kind of, being a part of a startup that goes into, big company world, and the differences in customers and the differences in just how you think about applications as a developer, right? Because a lot of people at ServiceNow, a lot of their customers are, these massive, tens or hundreds of thousands of employees, and they do have, thousands and thousands and thousands of applications. And I think that you can
Oh.
see where APM came from and really who it's for by looking at sort of those companies, right? Those organizations. Because if you are, a very large food manufacturer or soft drink manufacturer or consumer products company, you probably do have thousands or hundreds of thousands of applications. And I think it comes from that older model of thinking about, performance and monitoring, right? Where the system is not, where people don't think about systems as kind of this holistic thing. They think about them as like, this is an app that does this service, and I just want to know what's the performance of this, right? What is, what are all the applications that do, make this report or that report or this specific thing. And observability teaches us, I believe, that we should think about systems more holistically, and that's where this transition, that's kind of the inflection point, right? Is the system one application, or is it all these applications? Is it all these things working in concert?
Okay, so APM then is coming out of companies that have thousands of applications, and they're like, what even are these things? I need to track them, and are they fast enough?
Fast enough, good enough, yeah.
Good enough? Okay,
Oh,
yeah.
good enough.
Are
Good
they
enough is a
performing? And so is the audience for APM, is that like the business people? Is it the C-suite VPs? Um, who puts APM into an
I think the big thing with
organization?
OPM is they try to boil all of those applications down to the same thing with the same ideas of what good or performant
Oh.
looks like. And
Hmm.
that raises up to people who don't work at the lower levels, like the developers and the people who write the code. So APM, in my opinion, the people who want it, the people who use it, are more the people who are removed from the applications.
Mm.
So ops people would be a big example of that, where they
Wait,
don't.
ops are removed from the applications?
Yeah, so I'm talking about old world pre DevOps as a thing where you would build your thing, you would throw it over the wall, somebody would then go and work out whether it's working day in, day out, all of that kind of stuff, and the application developers
Wow.
wouldn't do those things. And I think that's where APM comes from, is this world of, I don't know about your individual context in your application, and I largely don't care. I've got, like Austin said, I've got hundreds of applications that I need to monitor, and I need to know, are they running fast enough? Are they having enough errors? All of that kind of stuff. I mean, we can go back to AppDex as a metric that a lot of the APMs
What's
still use.
AppDex?
Um, it was some kind of number. I never really understood what it was, but it was a number of how good is my application right now. But that's the sort of thing they wanted to boil it down to. My
Okay.
hundreds of applications, boil it down to one number so I can say it's not working well and send it over to the developers to fix it.
All right. I'm starting to see why this is appealing to large corporations because it's about legibility. It's about treating every application in a uniform way. and yet completely unappealing to developers. I never used APM when I was developing enterprise Java apps, because as a developer, I care very much about what individual apps are doing and how they connect and how they work together and the system as a whole. And that's exactly the opposite of what we're getting when we try to reduce things to one number.
Yeah, I mean, I think that in a lot of ways, this is one of the things I've been very passionate about as part of Open Telemetry, and I think that the project does a lot to try to combat this. And it's this idea that I think, and maybe if I was willing to throw stones at myself, I've certainly helped this perception over time that tracing is kind of like the new APM, or that tracing is like a replacement for APM. But tracing, metrics, logs, these are all just signals, right? And signals don't define your observability. And like the type of data you're getting, the quantity of data you're getting, like, yes, these matter. Like, these are part of it. If you don't have the right types of signals, if you don't have enough of the right type of data, then yes, you will have poor observability. But observability is really this, holistic understanding of the system and what it does, right? It's taking into account things like, I know you all, my good friends at Honeycomb, love to say, like, was it nines don't matter if people are if people aren't happy? What's the charityism?
Nines don't matter if users aren't happy.
Exactly. Yeah, I've seen some stickers. But it's true, right? Like, and this to me is like the flip, the switch that needs to be flipped in people's brains. And I think OpenTelemetry can help with this, because it builds on what is a traditional APM signal, right? The trace. Like, when people think about APM, I think they think about those, icicle graphs or those waterfalls.
So a trace really does come out of APM?
I would say so, right? Like, in the sense that APM differs from like traditional metrics and logs as being a way to quantify application performance.
Okay.
But what I think differs really, or one of the key things, is that APM tries to like you said, it normalizes this, right? It puts it in a box and it says, like, we, the people that create the APM suite or whatever, here's what matters. It's your AppDex score, or it's this particular code path, or it's
your nines of uptime,
or your requests per second, or
yeah. It doesn't. It basically says this is what someone else thinks is important. And observability, I feel like, is a lot more about, like, everyone's going to have things that are important. The importance differs based on who you are in the organization, where you sit. Like, are you a developer? Are you an SRE? Are you a business analyst? Whatever. The role of the technical side of observability, I think, is having this really robust model of your system with really high quality data and telemetry that allows for different users, different people in the org to ask interesting questions and get good answers back.
And when we talk about tracing here, I want to define tracing because not everyone knows it. A trace is a record of a request came in, it went to this service, and then it called this other service, and this took that long, and then it called this other service, and this took that long. So it is giving you detailed performance information. Then we talked to the database, and it took this long, which would be necessary for improving application performance. But the way traces are used in observability is about noticing those connections.
So one thing I want to, there are about 17 different overloaded versions of what trace is.
Yes.
And I think that gets incredibly confusing. You work in the
I'm
.NET world,
about a distributed trace.
Yeah. Tracing can be lower, it can be higher. So when we talk about tracing and what we're talking about tracing today, that's what you were saying is exactly what we're talking about. But I think it's important to acknowledge that when other people see trace, you need to understand what it is that you're trying to talk about, because it doesn't mean the same thing in all of the contexts.
You can do tracing at an operating system level of what files were accessed and stuff. And that's not unrelated. But specifically when I talk about tracing for observability, and it sounds like this grew out of APM even, it's about how long did each application take as part of servicing this request.
I think these are the desires that came out of this original APM. We want one big metric. Great, okay, we've got the one big metric. And then, oh, but we need a bit more information, right? What's the next level of information we might need? I think the origin is that individual top level word. And then you go a level below and go, oh, we want this. And then we said, right, great, we've got all of this, the tracing data. So, you know, all the tools have had this for many, many years. When the sort of big old school APM vendors, they've had the idea of a trace, even very close to what we're talking about today, inside of an individual application for quite a while. The distributed tracing elements is what I think has taken this to the next level. So the idea of being able to trace a request through methods, you know, I come from the .NET world, and having a trace through a .NET application is something that's been there for a long time. There's lots of tools that say, here's my trace, here's every single method that was called during this particular request that happened.
So more like I would call profiling.
Yes. Yeah.
Well, I think to add on to this, right? Like the other thing that's changed, and I think, and it's important to like contextualize all of this in, as you said a little while ago, Jess, right? Like pre-DevOps, you know, applications and how we even thought about like deployments and how we thought about platform, you know, internal developer platforms, and all of this has changed so dramatically over the past 10 years, even 15, certainly. It used to be when you wanted to deploy an application inside even a fairly modestly sized software organization, right? Like someone had to go and go down to the ye old server shop and like buy physical equipment and plug it in, right? Like if we didn't have enough servers to you know, provision you a new, you know, virtual machine on, or we didn't have enough storage, or we didn't have enough bandwidth or whatever, like these were problems that had to be solved with physical hardware.
And it was fantastically expensive because their department had to charge you not just the cost of the box, but the cost of forever maintenance because they didn't have a budget for that. That was my experience.
And then you couldn't even, so maybe you can't even deploy. It's like, maybe it's like, hey, maybe I've got like some cool new app or service or whatever that's going to save my team or this other team a bunch of money, but I can't deploy it because IT doesn't have the budget to go in and buy and rack this new hardware and support it for 3 to 5 years, right?
Right.
And so the cloud is what in a lot of cases has been sort of the transformational lever, right? It's the thing that pushes all this forward. And the cloud has given us, you know, I think a lot of stuff about why distributed tracing is more popular now and why it's important, or why its importance has changed, is due to that, you know, rise of the cloud, right? Because now you don't have to have a development shop that is, you know, vertically integrated into a single language. The idea, I mean, obviously there are still a lot of places that are mostly, you know, this is mostly enterprise Java, this is mostly enterprise.NET. But even within those, you're starting to see like people pull stuff in. So maybe you're a .NET shop, or a Java shop, but it's like, well, we've got this cool new generative AI stuff, and all those people are writing in Python. Maybe we've got, you know, mobile apps that are being written in Swift or React Native or whatever. So we're starting to pull in more, you know, more and more places are becoming truly polyglot because our abstractions for deploying software has changed. It's not build a server, rack the server. It's Kubernetes, it's Docker, it's serverless, it's Lambda, you know, whatever, right? And that's led to, it's self-serve, it's polyglot. And so we don't necessarily need these vertically integrated sort of traces anymore. We rely more on open standards and projects like Open Telemetry to give us the way to build this sort of telemetry infrastructure across different services, you know, different languages, so on and so forth.
Yeah. It's not cookie cutter. You just have to, your app has to fulfill an API that lets it fit in the organization.
Yeah.
I find it interesting that, Martin, you said that back in the glory days of APM, Ops was trying to treat every application as a black box, as the cookie cutter, but yet they had pets in the servers that were plugged into racks. And now we've got the servers are cattle, the servers are unnamed and in the cloud, and spin up on demand. But our applications, we're recognizing they're the snowflakes, and they're different, and we want to really look at them and understand them.
Yeah, yeah. I think this all comes down to how customers' expectations have changed, which is how we've changed the way that we build and deploy applications. The idea that now, if something takes more than 3 seconds, people are just going to go elsewhere. So we care about more things. We care about those interactions between services way more than we did. There's also this idea of, well, we need to get the feature out tomorrow. We can't wait for IT to rack that server. We need that tomorrow. And we need to know that it's up and running. All of these customer expectation changes are the reasons why we've had to change the way that we develop software and we deploy software and we observe software. Because as our customers' expectations change, we need better tools. And this is something I talk about a lot, which we can't expect people to have more expectations put on them as in developers and infrastructure engineers and DevOps engineers and all of those people who make up a team of people that deliver value to production. We can't ask more of them without giving them better tools. We can't say, this is the thing you had before and we expect you to do better. Well,
also,
okay.
You need to understand Kubernetes and Docker.
Yep. And C groups and all of the things that come with it. And why does this not work? I sudoed into it.
And IAM permissions and AWS.
Yeah. And
right. So we need to give them better tools.
And all of that is the reason why the old school APM approach of treating everything the same isn't really working. And that's why APM has evolved. And that's why we've got into this idea of, well, observability is the thing now. Because now all of a sudden, these interactions between all these machines and all of these services, which we've had to do because of our customer expectations, are actually way harder now. And now all of a sudden, we've got this idea of things going wrong in weird and interesting ways that aren't just that you deployed some code to that server and now that server's changed. It's, somebody's now using iOS 14.1 and that doesn't work with the French language pack when you're actually in Norway. These are things that you wouldn't have had a problem with before. And now all of a sudden, all of these different interactions between different services are really a problem. And APM has now evolved to the ability for us to ask those weird and wonderful questions.
Okay.
I do think
so. Go ahead, Austin.
Oh, well, I think on that point, like, it is worthwhile to but to consider that, APM is also like a bit of a moving target, right? Like I've talked to a lot of developers that use kind of traditional APM tools still in 2023, 2020, and I think you brought this up, right? Like there's a lot of like really interesting emergent problems in modern software. iOS 14.1 with the French language pack in Norway, but a lot of developers are just looking for like why database queries slow. And
that's still a thing.
And I think that is one of the
unfortunately, yes. Can we just get rid of databases?
One of the challenges, I think. This is a big challenge, I think, for Open Telemetry as a project, but also for us as like observability professionals, practitioners, whatever you want to call us, is like you need to serve both groups of people, right? Like, and how do you do that? How do you build tooling at sort of the framework level to make easy questions easy, but also to support like the hard questions being hard? And I think this is something that everyone it's a journey, right? Like nobody has 100% of this, but it's definitely it gets very easy to like stick in your craw about like, the fun, interesting, like crystalline fractal possibility space of observability. and we shouldn't leave behind the people that are just not quite there yet.
Yeah. Yeah. All right. So what is the promise? What is the new what has APM evolved into that we decided it had a new word, observability?
I think to me, this comes down to the ability to ask questions. I said where APM came from, which was boil everything down to one number. I think where APM and where now observability fits is that one number's great, but when that one number happens to be not good, how do I ask the questions that allow me to get to a really complex answer very quickly?
Okay. Okay. So now we're talking about, among other things, when incidents happen, how is it different? How is our reaction different?
Well, to your point, right? Like you said, like, how do I get those hard answers? To paraphrase, and I think that is one of the biggest challenges that a lot of organizations face right now, especially ones that are kind of in the middle of, they're going to the cloud, or they're going to cloud native, I should say. Maybe they're not going to the cloud, but the more layers of abstraction and the more things you add, like, the more stuff that can break. And when those things break, if you don't have like a lot of operational expertise in Kubernetes or in, IAM permissions or whatever, then you're going to have worse incidents for longer. And you're going to be kind of up the creek without a paddle. Not going to say what's in the creek though. But this is actually, I think that is like the key thing, right? And this is why I like to say that observability is really about being able to model, like, how do you know how good your observability is? With APM, it was fairly straightforward, right? Like, you look at the number and you say, like, well, the number is like, it's 90, so that's good. That's a good score. If it's 50, that's a bad score.
But we're customers happy.
Right. Happiness is very hard to quantify. 90
customers happy.
Like, it's hard to quantify happiness. And so, we can do NPS, we can do all sorts of things. I like to say that, the way to think about observability, the way to score it almost is to say, is to look at it and say, like, well, it's almost like playing an RTS or a map game, right? Like Civilization or StarCraft, and you've got the map. And how much of the fog of war, how much of the fog of war do you have? How many things are out there in the darkness that you can't see? If you have good observability, then you have that map, and you can see everything that's going on. You might not always have the context to make sense of it. You might see, like, there's some stuff moving around over here, and I don't really understand why. But if you have good observability, then you can at least see it. And the next step is, now you have tools that can help you give you that context and help you analyze it and help you make sense of all the different dots that are moving around.
Okay.
And that, I think,
so
is
tools that go a lot deeper than a big number.
Yeah.
Or a bunch of graphs that are the same for every application.
Right. Like, what do the graphs give you? If you don't know what the graph means, like, you're either in the situation of, like, being a person designing the graph saying, like, well, I have to distill down this potentially incredibly complex, application behavior into, like, number good or number bad. And that's always going to be very lossy. Whereas if you flip it around, you say, like, okay, my job isn't to understand everything. It's to have a tool that can help me ask good questions about this really good map of my system that I've devised. I think that makes a big difference.
To already understand everything. It's to be able to acquire that understanding when you need it.
Yeah. Just in time understanding.
I guess about going from that macro level down to that micro level. Can we still have that macro level of big, good number, bad number, caveman, woo, good, bad, woo. Can we go for, I've even got the beard, so I can be a caveman, just to be clear. Can we go from that big macro number that's really coarse-grained, but is very orientated around our customers, so being customer-centric, and are our customers affected by it? and then going really down to that micro level from that to be able to say, but why? Why is that customer having that particular problem? That's really, to me, that APM style stuff.
Yeah.
Nice.
Where we should be going anyway.
Yeah, no, it's
so connecting.
It's still
These
valuable.
things connect.
Yeah. It's all connected. It's all related. Everything. It is a crystalline fractal of possibility. I think the hardest thing is, one of the biggest challenges I've found, especially going into, very large enterprises and or people that kind of came up in people that haven't had their road to Damascus moment yet about observability and the cloud is trying to help educate them. It's like, look, a lot of the things that or that you think that you've been trained or taught or learned over the years don't make sense in the context of like a cloud native application, right? Like if you have a app running in Kubernetes, then it really shouldn't matter if the app crashes, if one part of it crashes, right? Like that's the point is that Kubernetes sort of does that stuff for you. If it crashes, it restarts. And then you design your system in a way that if it happens, it doesn't matter. Like, yes, there will be something will go wrong, but the overall system will be resilient to those failures. And that's
build a reliable system out of unreliable parts.
Yeah, but that's actually really wild if you think about it, right? If you've been in software for a while, I'm 40, like my first, computer job was working on the website for my hometown newspaper that ran off of a Quadra sitting under a desk, right? If I kicked the power out, then, well, nobody's reading the news tonight. And that mental model, I think, is very prevalent, that servers are still a thing and that system, that they are logical masses that we have to, think about like that. And it's like, no, they're really just, they're Schrodinger's cat. It's a box. And if you observe the box, the state of it will, the state of the API will change in many cases. And we have to be comfortable and we have to like sit with that sort of discomfort about not really knowing, not really being able to have the big dashboard with all the lines and numbers that say everything's good, right? Because if everything did show up good, that would actually probably be scary. Because that means like nobody's using it.
Because in a big enough distributed system, something is failing all the time.
Yeah.
So but customers can still be happy.
Exactly. And they should be. And if you've done it well, right? If you've put all this stuff together well, then they will be happy because. But how do you know? And then that takes us off to other magical fun lands.
But yeah, something I talk about. Well, something I talk about quite a lot is this idea of you walk into a room in the workshop and you have to tell people, I'm really sorry, but your system is broken. I don't know what you write. I don't know what your system does, but I can tell you it's broken. It's all really a matter of how much broken are you willing to accept? And then being able to monitor to make sure that that level of broken never is exceeded. And that realization, that's that road to Damascus moment of understanding that, yes, it's broken, but I need to know how broken so that I can work out whether I accept that.
And by road to Damascus moment, we mean a light shines out of the sky and suddenly you understand everything?
Oh, you understand why.
Your heart
You understand
changed.
Something. Your heart has changed. All right.
That's how I describe it, at least. I tend to view it as, this very being comfortable with unknowns, right? Being comfortable knowing you know nothing. Because I feel like that's the hardest part, I think, of like the observability journey for people is getting to the point where you know that there's just a lot of stuff that you can't quantify, and being able to convince other people in your org or on your team or whatever that that's okay.
And proceed with confidence anyway, because you know when the system becomes too broken, you have what you need in order to fix it.
Yeah.
That sounds like a good place to move to questions, because I think our audience has put some questions in. Keith, what do you have for us?
All right. What a great discussion, everyone. I learned so much about this topic. And you're right, Jessica, we have got some fantastic questions coming in. So let's get to some of those now. Okay. First thing, Rayudu wants to know, what are some best practices for implementing observability in software development?
Martin, I believe you have opinions on this.
Me? Opinions? Never. I don't have opinions. I would say best practices are generally start with the automatic stuff. And that will get you a lot of the way towards what you may have seen with APM.
What's the automatic stuff? What are you talking about?
The automatic stuff would be, there are sort of three phases, if you like. We've got agents, which is more akin to what you might have had with an ABM agent, where you install it at the side of your application. And you can generate traces and all of that data to send to a vendor, which is a really good starting point. If you're on Kubernetes, we've got things like the hotel operator, which can do all of that automatically. And that's a really good
OTel, you mean
point.
Open Telemetry, which Austin has mentioned a couple times. Would you define Open Telemetry for us?
I will let the person on the GC of Open Telemetry take that question.
So Open Telemetry is a Cloud Native Computing Foundation project, CNCF, same people that bring you Kubernetes and many other popular open source projects. And the goal of OpenTelemetry is to provide really a standard for defining software telemetry. Telemetry are signals that you get out of an application that tell you what's going on. You probably are familiar with things like logs or metrics. OpenTelemetry is a data model, an API, a way to kind of express what those signals are. And then a tool set for collecting that telemetry, transforming it, and sending it to any number of both open source and commercial vendors to analyze it. Some of the great things about OpenTelemetry is it means that you can you can instrument once, right? You can write your instrumentation code in OpenTelemetry.
Means to add code that sends telemetry.
Right. It's basically creating these signals in your code, and you can use that with a variety of places. I'm pretty sure Honeycomb is one of many companies that accepts like OpenTelemetry data. The other really great thing about OpenTelemetry, and this is sort of a looking forward thing, but by having the entire industry really come together and align behind this one standard, it means that a lot of that telemetry can be baked in. It can be native instrumentation. So in the future, your web framework, your API framework, your web server, whatever library or database you're using can just natively emit OpenTelemetry data. And then you can take that and use that for observability purposes.
And then you don't need those agents that, Martin, getting back to you, you were talking about the OpenTelemetry agents as one option for getting started.
Yeah, so in terms of getting started and implementing observability, it's the easy mode would be installing an agent that automatically does all this and gets to what we were talking about before about boiling down applications to one thing that an APM would do. So the automatic agents will do the basics, like I called another third-party API, I hit a database, and some of the more popular libraries will automatically be instrumented, which will provide you with a nice basis to then move on to providing your context into the application. So your client ID, where your client ID is, where your tenant ID is, where your user ID or order ID, which might be important to you when you're debugging. So starting small with just let's put the baseline instrumentation in place, then moving on to actually starting to think about your own context. And that's where you start to get that real value.
You said user ID and customer ID. And coming from maybe a place of dashboards and metrics, I have been told never to put fields like that on my data because it'll just explode the cost of saving it.
It can, and if you are using metrics as your primary signal, then yes, absolutely. If you're using metrics, that isn't something that you would put in there. But if you're using tracing, which is kind of the gold standard for observability, then it shouldn't matter because this is raw data at that point. So it doesn't change the cardinality. And generally tools, especially like ours, a honeycomb, will be able to do that at runtime. So it doesn't really cause a problem and can provide you with some really, really in-depth analysis.
So this is another level of data granularity than we were used to back in the days when APM was all we had.
Yeah. When all we had was the number of requests per second, the concurrency rate of requests,
you wouldn't save the number of requests per second per user. But when you're saving a little trace of the request, yeah, you might as well throw user ID on there.
Exactly. But yeah, that's some, getting started. Obviously, there's way beyond that. Observability is a really rich subject to delve into, and like fair warning, it can get really addictive once you get started with putting stuff in. You're like, oh, it'd be interesting if we could, which is a rabbit hole that you need to really pull yourself out of sometimes.
Is there a good kind of viral going on here while we're preventing incidents?
Indeed.
Okay.
Yeah, you can get spoiled knowing what's going on. Oh, yeah. Keith, go.
Yeah, absolutely. Sorry. So Brandon has an interesting question. He asks, what are the benefits of observability for modern cloud architectures and distributed systems, which, to me, pretty much encapsulates all efficient environments these days. And I'll throw that over to whoever wants to answer.
I suppose I can take a stab at it. I think in many ways, that's what we've been talking about the past 40 odd minutes. But to make it a little bit more concrete, right? Imagine that it's 3 a.m., you get paged, and your team is in the middle of a big migration project from, maybe some legacy API server to this fancy new Kubernetes-based thing. You've got Envoy, you've got all sorts of technologies that you've read about. You maybe read some talks, gone to some talks and seen about, and it's all really cool, and everything's been working great. And so last night you decided, all right, we're gonna throw the switch. We're gonna start routing, 10% of traffic through, and you get paged because suddenly everybody that is 10% of requests going through it are getting really strange error messages, and it doesn't seem to be the same one every time. Sometimes it's a 500, sometimes it's a 402, 403, 404, whatever. And you are presented, your job, you are the first responder here, right? Like, your job is to triage, your job is to figure out what resources do you need to pull into this. And so using all of your skills and abilities, you start looking through logs, and you have, let's say, a modest size cluster of a couple hundred nodes. What do? Well, you've got a bunch of logs, so it's time to start searching through the logs. But it's really challenging because, like I said, it's not the same error message all the time, and it's not every single request. So you're trying to group stuff. You see on on some metrics that, like, CPU utilization is a little weird over here, and memory is a little weird over there. And there's this weird thing about, like, pods not being able to schedule, and taints, and some words you're not quite familiar with, and Googling and Stack Overflow is not being super helpful. And it's also 3 a.m. And why are you doing this? You really shouldn't have had that drink last night. What do? Right? Observability does not give you the answer. Observability is not being able to say, is not being able to log into a page that says, here's what's going on in plain English. But it's also not just having all that data, right? A lot of people, I think, would tell you that observability is when you've got all this data together and you can go look through it. Observability is in my opinion, is that you have enough of this data and you have it together in a way, and it's connected in a way that you can go into an analysis tool and you can start asking questions like, where are all these 500 errors? Is there something in common with everyone's getting a 500? Is there something in common with everyone's getting a 404? It's like, okay, there's a couple things that are in common. They're going to this particular node, or they're going to this particular region, right? And I don't necessarily need to be a Kubernetes expert to ask that question. I just know that there's a problem. I see what I'm getting paged for, and I can start asking that kind of question and then it starts a loop. And it's like, okay, I'm going to go on to these nodes. I'm going to restrict my query and scope it down. And it's like, what is different about these nodes versus those nodes? And so on and so on and so forth. And eventually you can figure out that, oh, there was a deployment where we changed the affiliation, or we changed the taints on these so that they will try to schedule the pods for Envoy onto these particular nodes, but this one over here had the wrong configuration. So all I got to do is change 2 lines of YAML and go back to bed. But you will never get to that point if you don't have good observability.
Nice. Thank you.
Yeah, for sure. Okay, I think we got time for a couple more questions. Here's one from Cal, who asks, how do you make APM robust? I mean, there's kind of a built-in assumption there that there are situations where maybe it's not robust. So can you address that first? And then second, he asks, is automation a possible solution? And I would rephrase that as like this. Is automation essentially these days a requirement?
Who has opinions? Martin, your mouth is moving. I know you want to say it.
I'm sorry. In advance. So there's this whole movement at the moment around machine learning and AI and all of this kind of stuff and how that can be used for observability. And I don't agree, other than for the basics. So the things that we talked about, the big number bit, yeah, we can absolutely automate that. The big number says this, and that's wrong. And we need to do something about it. We can automate a load of those things. We can automate things like error budgets for SLOs. We can say when those are going to go out, when we're going to run out of budget for these things. And those are all concepts that I'm not going to go into here, but there are basics that we can. The thing that we can't do is be able to know that a particular node has an old version of the software and it was deployed 3 weeks ago, and that was the thing when Dave was on holiday and he was drinking before he went on call and he pressed the wrong button. And these are the things that we can't tell a computer. We can't tell an AI model about these things. It requires human interaction because we're talking about new things. If it's things that we know, then we've probably got a metric. We've probably got a saved query somewhere that tells us about those things. We can put that on a dashboard. We can put that in a runbook that somebody can click on and see those things. The real benefit of observability is the unknown unknowns, the things that we didn't know that we needed to know until we needed to know them. And that is really where it comes to observability being a human thing. What we do, and one of our phrases at Honeycomb, is we don't build robots, we build mecha suits. We build this idea of advanced tooling to get you to the answers quicker. We're not building some robot that's able to do that idea of some automated robot coming to you and saying, there's a problem on this service in this particular area of code, go and fix it. And that's the close of my rant.
I tend to agree. I think AI is interesting. I've seen this from both sides, or a bunch of different sides at this point, I think. And in a perfect world, here's what I think AI is useful for, right? I think that if you have this highly structured data, which OpenTelemetry does provide, right? It provides this very good model for things, that there are interesting applications of machine learning built on looking at those in aggregate and saying okay, we have this, we know what a Kubernetes cluster looks like, we know what your application looks like based on this data telemetry you've sent, and we can make some, not even educated guesses, we can actually maybe do some prediction, or we can look at stuff. But that's not what people mean when they say like AI ops these days. And what I've seen a lot of is, a lot of people that talk about AI ops or AI alerting or whatever, it's just like you're getting a bunch of alerts about the same thing, and we're going to use machine learning to like consolidate those. But that's like a systemic problem, right? Like the reason you're getting a bunch of duplicate alerts is because the way your thing is set up. I don't know. I think I've been thinking a lot about it. I don't know. There's still just like this big gulf, I think, between like people that are what people mean when they say AI and what people are selling you when they sell you AI. I do think one thing that's very interesting, though, especially with large language models, is the ability to do like to use natural language for querying in an observability context, because one of the more challenging things when you have an incident is having to kind of remember, do I use PromQL for this thing or that thing, or just the different dialects of query languages. Having like being able to just say like in human language, hey, this is what I want, is really cool. So we'll see. I know
So in
Honeycomb
the
does
end,
something
it's
like
still
that.
a human being augmented
Yeah,
by
yeah,
the software.
yeah. But it's machines. What's the IBMism? A machine can never make a management decision because a machine can't be accountable. Like at the end of the day, like AI and all this is just it helps you as a person do your work better so that you can do things that aren't your work faster.
On the other hand, you do need your observability to be robust. And there is a lot of automation behind that, behind gathering the data, behind emitting the data, behind putting it together and showing it to you and responding to queries. And that part's essential.
100%. 100%. What a fantastic overview of a complicated topic, and one that, in my opinion, doesn't get enough publicity. But I think this has been really useful for everyone on here. Looks like we're running out of time now, but I did want to ask you, Jessica, one last question. So this has been a really great neutral discussion of all this. But if somebody does want to get started with Honeycomb, or find out more, what do you recommend they do as the next step today?
Oh, great. So you can go to honeycomb.io and sign up for a free account. And then you've got to send it some data, which is fun. You can do that from local development. The other thing that you can do is go to play.honeycomb.io, and there you can work on an existing set of data with an application that has a problem, and you can get the experience of asking questions and saying what is different, and doing that kind of debugging experience that is going to save your incident from going stretching into hours and days when you might be able to narrow down the problem in 15 minutes with good observability.
All right. Hey, free troubleshooting. Who doesn't like that? Jessica, I want to thank you so much, you and Martin and Austin, for being on with us today, for putting together such a great presentation, for your insights in the Q&A. It was a real pleasure to have you on.
Thank you, Keith. It was great.
And with that, we are close to wrapped today, everyone. We do have one more piece of business, of course, which is the Amazon gift card prize drawing before we get out of here. And we do have a winner today. Remember, as I mentioned at the beginning, that you have to be present for the entire event to be eligible to win the gift card. And the winner of today's $250 card is Lavenish Sedana from Georgia. Congratulations to you, Lavenish. We will be in touch ASAP to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank honeycombio for making this event possible. And I want to thank all of you for being here today, for attending, for your great questions, for being so engaged with this topic. I had a lot of fun, and I hope you did too. So that concludes today's event. Have a great rest of your day.